Hi everyone, this is the first recording for day 4. So we're going to be tackling copolygraphs part 2. So to begin, we are going to talk about symmetry of polygraphs. So far we've been dealing with polygraphs that is based on sine of theta or cosine of theta. So let's just jog back our memory and do a quick sketch of sine theta. Okay, so sine theta is, remember, if whatever the full period is, I'm going to use 4 notches if I was to graph that. So full period for sine is 2 pi. That means half of that is going to be pi right here. That's going to be pi over 2. And that's going to be 3 pi over 2 here, right? And remember, sine curve is always my S shape, reverse S shape. So it's going to be at the origin, up, down, at the origin again, and then looks like this, right? And if I was to continue that pattern, it will look like this on the other side as well. Okay, so I'm going to sketch the sine curve. It should look like this. Okay, a good revision in preparation for the finals. Okay, so that's what sine graph looks like. What about cosine? Same thing. I want you to try to do that too. Okay, so here is my cosine graph. Remember, cosine graph is my cup, right? That looks like a C. Okay, so now looking at this, can you see that if I was to this graph right there, this is as if I can make this a reflection if I draw a straight line down here. Okay, so if I put a mirror right there, the left hand side of the mirror is going to be a reflection of each other. So this tells me that sine is going to be symmetrical, but what is this? This is a line that says theta is equal to pi over 2. So this is going to be symmetry about theta is equal to pi over 2. Okay, so if I was to draw a line right there or put a mirror there, okay, and on the polar axis, pi over 2, on the polar graph, pi over 2 is the vertical line, right? So this is my 0, this is pi over 2, and this is pi and 3 pi over 2. My pi over 2 line is going to be my vertical line right there. Okay, so this is my vertical line. So symmetry about the vertical line in the polar graph. Okay, so what about cosine? Well, it looks like if I put my mirror right here, it's going to be left and right hand side of it is going to be a mirror image or reflection of one another. And where is that line? That's when theta is equal to 0. So this is the cosine function has symmetry about theta is equal to 0 degrees or 0 radians. And that is my what we call the polar axis. So 0 degrees on the polar graph is what we call polar axis, or sometimes we can call that the horizontal axis. So that's about the polar axis or horizontal axis. And here's a quick sketch of that information here. So on the polar graph, it's the polar axis that is going to be symmetric. The polar graphs are going to be symmetric about. If we're dealing with cosine of theta, if it's sine of theta, it's going to be the theta is equal to pi over 2 or the vertical line. All right, so how is this going to be helpful for us? Well, if you are asked writing different equations with equivalent graphs, we're really talking about symmetry. Okay, so to find the different equation with equivalent graph to a given equation, what you need to do is, if you're dealing with sine, so for sine polygraphs, you need to replace r theta with negative r comma negative theta. Okay, so what that means is for the sine graph, okay, we're going here. What that means, if I am dealing with some, so you basically are looking at when is the theta and negative theta is going to give an opposite value. Okay, opposite value. Here, if I have a value, say, some theta here. Okay, and then in the negative direction on the same, this will be negative theta here, negative theta here. The value for the sine is going to be exactly the same value, magnitude, but opposite in sign. So that means the radius has to go in the opposite direction as well. Okay, so what you can do is you can replace r and theta with negative r and negative theta if you were dealing with sine graph, or if you're dealing with for cosine graph, okay, so or cosine equations, you can replace r and comma theta with, in this case, negative r and pi minus theta. Okay, and let me demonstrate why that works. Okay, so if I have my cosine function here, so if I have some angle right here, let's just call this theta here. Okay, and what actually happens is this value here is going to be reoccurring right over here with opposite sign. This is going to be theta pi minus theta, because that's going to be whatever theta angle is, you're going to subtract from that. So this is going to be a mirror image, right? So, but it's going to have the same magnitude but exactly opposite in sign. So that's where r and negative r comes into play. Okay, and we'll see how it works out with examples. But before we get started, one thing I do need you to remember, recall back from trigonometry, is some identity alert. So identity alert. Okay, do you remember the even and odd identity, which said that cosine of negative theta is same as cosine of theta? And that comes from the fact that cosine of negative theta, if you are dealing with negative theta, oh, here we go. Cosine of negative theta, I was thinking, that does not work out. Cosine of theta is going to be same as cosine of negative theta right there. We're going the same distance on either direction. That's because it's symmetrical about the polar axis, or theta is equal to 0, right? So it's a mirror image right there. So that's the even and odd identity that comes into play here, as well as the sine of negative theta is really same as negative of sine theta. That's one of them. Okay, so if I have sine of negative theta, then it's same as taking the sine of theta, but taking the negative value of it. So that's why it is going to be exactly the same. So that's the first identity alert that you need to keep in mind when you're solving problems that ask you to find the equivalent equation. Another thing that you need to keep in mind is sum and difference identity, and which says that cosine of a minus b is same as, remember cosine is cosine, cosine, sine, 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 cosine a, cosine b, and then change the sign, sine a, sine b. So cosine, cosine, sine, sine, sine. That's the other identity alert. Okay, so keep that in mind as we are trying to solve some example problems. Okay, so we're going to try two different problems. if I asked you find another equation with the equivalent graph to first r is equal to 3 minus 4 sine of theta. Okay, so with this is my sine graph. Okay, so with sine, if r and theta gets replaced by negative r and negative theta. So what I'm going to do is I'm going to change the r to negative r, and the theta gets changed to negative theta, and everything else stays the same. Negative r is equal to 3 minus 4 times sine of negative theta. And then from here, you need to simplify this. Okay, so what is sine of negative theta? So my even and odd identity tells me sine of negative theta is really same as sine of negative of the sine theta. So I can say that this negative r is equal to 3 minus 4 times, now this becomes negative sine of theta. So you're multiplying negative 4 times negative sine of theta, so that becomes positive 4. Negative times negative is positive 4, so that is same as 3 plus 4 sine of theta. So negative r is equal to that. So taking the negative of both sides, so r is going to be equal to negative 3 minus 4 sine of theta. So this tells me that this equation here is an equivalent equation. Equivalent equation to this. Okay, see if you can do the same thing with b. Pause the video and see if you can tackle it yourself. Okay, so in this case, it's cosine function. So for cosine graph, I am replacing r with negative r and theta with pi minus theta. So this gets replaced by negative r, and this gets replaced by pi minus theta, and everything else stays the same. 3 minus 4 times cosine of pi minus theta. Okay, and then from here, 3 minus 4 times cosine of theta, pi minus theta. Cosine of sum and difference identity says this is going to be same as cosine of a. This is my a, this is going to be my b. So cosine of pi, cosine of theta, plus sine of pi and sine of theta. So that's what negative 4 is being multiplied to. So we have negative r is equal to that. Now we just need to simplify. Negative r is equal to 3 minus 4 times, what's cosine of pi? That's negative 1. Times cosine of theta, plus what is sine of pi? Sine of pi is 0. And that's multiplied by sine of theta. And 0 times anything is 0, of course. So this goes away, and you're just left with this. So that's going to be 3 minus negative 4 times negative 1 is going to be positive 4 cosine of theta. So negative r is equal to that. And then from here, taking the negative both sides, so that's going to be negative 3 minus 4 times cosine of theta. So that's my equivalent equation. Okay, I am going to continue with the next topic in the next recording.